Good day, this is Bennett, also known as Jeremiah. Today we're going to talk about electrolysis of ionic compounds. So we're going to talk about the explanation including past papers. If you're interested in more videos, the playlist is found at the end of this video. It is also found right here on the top right of the screen at the suggested video. So let's begin. Alright, let's talk about electrolysis of ionic compounds. So this is where a lot of students get it wrong. So first I'm going to explain the technicalities for around 2 minutes so that you get the general application so that you're able to apply skills in different questions. Then afterward we'll do some past papers. So after this, you should not miss marks. So far we know that electrolytic cells are usually in one beaker, right? So then we're going to have electrodes. And then we're going to have an external circuit, right? So for now, let me put a positive terminal over here. So sometimes we've got an external circuit, sometimes instead, or rather, sometimes we're given a battery, sometimes instead we're given this and are told power source. Whenever you're given this, we do not know which one is positive and which one is negative yet. So for now, let's just have a battery. So now let's just say we've got this electrolyte, right? So what is the electrolyte? So electrolyte is a liquid that something has been dissolved in, right? So, but that's not a definition. So if they ask you what is an electrolyte, you will say an electrolyte is a solution that conducts electricity through the movement of ions, right? So remember there is a solvent and a solute. So let me just explain this stuff. So it's not really going to be important. It helps in other topics, but here it's just going to help you a little bit. So there is what you call a solute, right? So a solute is the thing that you are going to dissolve, right? So maybe you want to dissolve a certain salt. This is going to be the solute. And then the solvent is the liquid that you're dissolving in, right? So in this case, our solvent is just going to be water, right? So there is a solute, then there is a solvent. So when a solute is dissolved in a solvent, then this whole thing will be called a solution, right? So now an electrolyte is a solution that conducts electricity through the movement of ions. What are ions? So when we dissolve NaCl, it's not going to remain as NaCl, right? It's going to split. So we're going to have Na plus and Cl minus. So now notice that these are called ions. So electricity won't just flow. We need to put something, right? We need to put a salt so that it can split into ions. Then electricity will flow because of these ions. So then this is what is called an electrolyte, right? It is a solution that conducts electricity through the movement of ions. So let's talk about this a little bit. How do we know that this is Na plus and this is Cl minus? And how do we know that oxygen, when it's an ion, it becomes 2 minus? How do we know? So let's talk about that. Alright, so this is how you know. So you use the periodic table. So everything in group 1, right, whenever it becomes an ion, it... Alright, so this is how you know. So everything in group 1, whenever it becomes an ion, it has a charge of +1. Everything in group 2, when it becomes an ion, it has a charge of +2. And then we just keep everything here. So here they have to tell us. If they tell us, for instance, it's chromium 3, then we know it's going to become +3, right? So now here, everything here, when it becomes an ion, it becomes +3, right? So here it's +1, here it's +2, we skip all this, then here it's +3, right? And then now here, just before the last, we don't consider the last group. So just before the last, it becomes -1, and then here, everything here, when it becomes an ion, it becomes -2. That's why oxygen is -2. So sulfur will also be -2, right? So everything here, when it becomes an ion, it becomes -3, right? And then these ones here in this group is in between, right? So notice that it's in between 1, 2, and 3, right? So it's in between these ones and these 3 as well, right? So I hope you get it. So this is like in the middle. So the ones in the middle can become +4 or it can become -4. All right, don't mind my handwriting because I'm not using a pen here. So it can become +4 or it can become -4. So it depends on the situation. For instance, if carbon was with oxygen, then because oxygen has to be -2, carbon will now have to be +4, right? So it depends on what it's reacting with. If it was instead carbon and hydrogen, So because hydrogen is positive, carbon would have to be negative. So that's how it is. So everything in group 1, so let me just repeat it one more time. So everything in group 1 has a charge of +1, everything in group 2 has a charge of +2, right? And then everything here has a charge of +3. And then here we've got -1, here we've got -2, and then here we've got -3. Then the ones in the middle can become plus or minus depending on whether they're reacting with a positive one or a negative one. So if it's reacting with something that is positive, it's going to have to be -4. But if it's reacting with something that is negative, like oxygen, then it's going to have to be +4. So that's how we know the charges. Alright, so now let's get back to this stuff. So let's just call this P, let's call this Q, right? So now these electrodes are made of things that don't react, right? They can conduct electricity, but they do not react, they do not form part of the reaction. So this would be maybe platinum or graphite. So if they ask you why is it made out of platinum, they can say electrode Q is made out of platinum. Explain why is it made out of platinum. Then you say that because it does not form part of the reaction, right? And also that it conducts electricity. So we use an aux to...
Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvement.
Memorize that oxidation occurs at the anode, right? So it's quite weird, but we use that to memorize that oxidation occurs at the anode. Then we use red cat. So we use red cat to memorize that reduction occurs at the cathode, right? So red cat, reduction occurs at the cathode. So how do we know which one is the anode, which one is the cathode? So in an electrolytic cell, the anode is positive and the cathode is negative. But it's not the same for the galvanic cell. This is where a lot of students make mistakes, right? So for the electrolytic cell, the anode is positive, the cathode is negative, but for a galvanic cell, the cathode is instead positive and the anode is negative. So now that we're dealing with electrolytic cell, we know that the anode is positive and the cathode is negative. So the one that is connected to the positive terminal of the battery becomes the anode because it has to be positive, and then the one that is connected to the negative terminal of the battery becomes the cathode. So I want you to understand that we know that current flows from the positive terminal of the battery to the negative terminal of the battery. So this is what literally what they can ask. And then, so they can ask you, they can say which direction does current flow in the external circuit, from P to Q or from Q to P, right? So in the external circuit, it flows from P to Q, right? Or rather from Q to P. So it flows this direction, right? So they can ask you which direction does charge flow in the external circuit, from P to Q or from Q to P. So notice that it flows from the positive terminal of the battery to the negative terminal of the battery, right? So it means current is flowing this direction. So from the positive terminal of the battery to the negative terminal of the battery, right? So if they ask you which direction is current flowing, from P to Q or Q to P, it's going to be Q to P, right? So that's how it is. Then they can ask you also which direction is the electron flowing. So notice that electron flows in the opposite direction of current, right? So while this current flows from the positive terminal to the negative terminal, electrons instead flows from the negative terminal to the positive terminal. So what I want you to know is that with the anode, electrons literally flows from the anode, right? So it goes this direction. So electrons flow out of the anode through the external circuit, right? So that's what happens. So it flows from the negative terminal of the battery to the positive terminal. So if they ask for electrons in the external circuit, then you say from P to Q, right? So that's how it is. So let's say they ask you write down the half reaction that occurs at P, right? So we know that P is the anode because it's positive. So what you have to know is that the positive, unlike charges, will attract. So this positive will attract this negative, right? While this negative will attract this positive, right? So it means chlorine is going to go to the anode and it's going to be oxidized. So that's what happens. So usually when something goes to the anode, it usually becomes gas, right? So you will find bubbles forming over here, right, at the anode. But now when something goes to the cathode, so the cathode is going to attract Na plus, right? So whenever something goes to the cathode, it's going to become solid. So that's why they say mass is gained at the cathode, right? So initially we had something perfect like this, and then now solid will start forming, right? So now we'll start having a surface forming around the cathode. So this becomes solid when it goes to the cathode. But when this one goes to the anode, it's going to become gas. So let's just deal with that question before we go to past papers. Let's deal with the question of write down the half reaction that occurs at electrode P. So we know that it's the anode, right? So it means that when chlorine goes there, it's going to be oxidized. All right, so now we are looking for chlorine, right? So I'm going to explain something. So what is chlorine? So this is table 4A, the other one is table 4B, but the method will be the same for both. So let me use table 4B. So chlorine is over here, right? So notice it's over here. So if they say write down the half reaction that occurs at the at electrode P, right? We know that it was the anode. So it means that this will get oxidized. Now I want you to understand something about oxidation. Usually the anode breaks down, right? So because the anode breaks down, it means we're going to have it from one compound to many compounds because it's a breaking down. So the anode usually breaks down, while the cathode usually builds up, right? Remember, things become solid, and that's why the mass is gained at the cathode, right? So there is always a building up at the cathode. The cathode kind of becomes bigger, but with the anode, there is always a breaking down. So because there is a breaking down, because it's oxidation, right? There is a breaking down. We know that it's going to move from one compound to many. So it means that you write it from right to left. But if this was the cathode, then it means that there was going to be a building up, meaning that two things will join to become one. So that's how it is. So for now, because it is the anode, we have to write it in reverse. So let me write it in reverse. So this is how the original equation was written. So because it was the anode, there is a breaking down. So it means it moves from one to become many, right? So it means we're going to write it backwards. So this has to be minus. This was actually minus. So then it's going to be 2Cl, right? Then we'll only write one arrow. Then it's going to be Cl2 gas. So notice that it became gas, right? So then we're going to have 2E. So that's how it is. However, not everything becomes gas when it goes to the anode, right? Some of them becomes liquid, right? So not all of them become gas. Some of them don't become liquid or gas. So when something goes to the cathode, there is always a buildup, right? So it becomes solid. So the cathode always gains mass. Then the anode usually loses mass. So this will be the half reaction that occurs at the anode. So now let me go deeper in this stuff. So now what I showed you is the general method, right? This is also what most students do, right? However, there is something that most people don't consider, and this is why they can get it wrong, right? So now let me show you the real stuff. So that is the method. That is actually how you should think. That is how you generally apply it. But now I want you to notice something about this stuff. Notice that this thing is dissolved in water, right? So inside water, so water can also form ions, right? So when water itself breaks up, so some parts are still liquid, some parts are in ionic form, right? So when water breaks apart, it's going to be H plus and OH minus, right? So let me just write it over here. So let me write OH over here, and let me write H plus over here. So there is something I want you to notice. Notice that this is positive and this is negative, right? So this positive one does not only attract this negative chlorine, it also attracts negative OH, right? And this negative one does not only attract positive NH, right? It also attracts the positive hydrogen, right? So it also attracts that proton. So what am I trying to say? These two actually compete to be oxidized, right? And these two actually compete to be reduced. So how do we know which one will win? So let me talk about this side first, right? So let's talk about this side first. So now, whenever there is a competition between a metal and a hydrogen, it will depend. if the electrode potential, when you look at the table, right? So when you look at the electrode potential table, there are some values there, right? I'm sure you're familiar with it. So if the electrode potential of the metal is positive, it's going to win. It's going to be the one that will be oxidized. But if the electrode potential is negative, like for instance in zinc, when you look at the electrode potential, you will see, I'm not talking about the charge, right? The charge can be plus, I believe it's plus, right? But I'm not talking about the charge. Yes, the charge is positive, but I'm talking about the electrode potential. When you look at that table, the values, you'll see that the value is negative, right? So whenever it is negative, hydrogen will win. Hydrogen is actually the one that will be oxidized. So I'm going to apply this in a question. I'll show you something, right? So that's how it is. So on this side, it's usually hydrogen versus the metal, right? So if the metal has a positive electrode potential, it will win, it will get oxidized. If the metal has a negative electrode potential, it will lose, right? So hydrogen will be the one that will be oxidized. So if they say write down the half reaction that occurs at the anode, what I did there is what most students do. It's actually wrong, right? What we're supposed to do was to take for hydrogen instead and write it in that way, right? It moves from one, it becomes many. So I'm going to do a practical one. We're going to do a past paper, right? So that's how it is. And then, so always remember that. So when there's a competition, if the metal has a positive electrode potential, it wins. If it has a negative electrode potential, hydrogen wins. So hydrogen will be oxidized. So the oxidation half reaction that you must write will be for hydrogen this time. So that's how it is. So Na actually had a negative electrode potential, so it lost. It was supposed to be hydrogen that was supposed to be oxidized. So hence I said what I did there wrong, right? So let's talk about Q. Let's talk about the cathode rather. So in the cathode, these two are competing. So how do we know which one will win? So in your mind, you must have two groups. In your mind, you must have two groups, right? You must think of halogens, right? So the first group is halogens. So in halogens, we know we have chlorine, iodine, bromine, right? Fluorine. So whenever it is a halogen, it will win. So you see, like in this case, we had Cl versus OH. So it was a halogen, right? So the halogen wins over OH, right? So whenever it's a halogen, it wins. But if it is a nitrate or sulfate group, so sulfate, we have got something like this. Nitrate, we have got something like this. So if, let's say, this was not NaCl, let's just say it was instead NO3, sodium nitrate, right? So if it was instead sodium nitrate, we know that if this thing splits in the water, we'll have sodium and then we'll have a nitrate, right? So if it was instead a nitrate, it will lose. OH will be the one that will be reduced. So that's how it is. So these two compete in order to be reduced. And these two compete in order, rather, these two compete in order to be oxidized, right? And these two compete in order to be reduced. Alright, so let's just check it. So we're looking for sodium, right? So where is sodium? Okay, notice sodium is over here. So this is sodium, right? So notice the electrode potential. It is negative. So whenever a metal is competing with hydrogen, if the electrode potential is negative, hydrogen will win, meaning that the correct one that we're supposed to write was for hydrogen. So meaning that we're supposed to write the oxidation reaction for hydrogen. So notice it's one, then it becomes many, right? Because at the anode there is always a breaking down. So that's how it is. So we're supposed to write this instead backwards, right? But if it was something else, maybe copper, copper would have won because the electrode potential is positive. So that's how it is. Alright, so now let's go deeper. This is where the majority get it wrong. So let's use the same situation. So we have Na. So let me just do this. So we've got Na plus, right? When we dissolve table salt, we're going to have Na plus and Cl minus, right? So I want to show you something, right? So I want you to be aware that these are not the only ions. It's literally not the only ions, even though we have just dissolved them in water. Water in itself can also ionize, right? So meaning some parts of water, the majority of the parts of water are liquid, then some parts also are ions, right? So just be aware that water also ionizes. So meaning that we're going to have H plus when water splits, right? And we're going to have OH. So what am I trying to say? Notice that this negative does not only attract Na, it also attracts hydrogen because it's also positive, right? It also attracts hydrogen ion. So this positive does not only attract chlorine, it also attracts this OH minus. So this is supposed to be OH minus, right? So what am I trying to say here? All right, so now I want you to be aware that it means that these two will compete to be oxidized, literally, right? So these two will compete to be oxidized. And then these two will compete to be reduced, right? So how do we know which one wins? So let's talk about this one first. So let's talk about this one. How do we know which one wins? So in your mind, there must be two groups, right? Halogens. So when you talk of halogens, we talk of either chlorine or, or bromine, right? Or iodine or fluorine, right? So this is the first group. The second group is either nitrates or sulfates. So sulfates or nitrates, right? So here's the thing. If it belongs to a halogen, it's going to win over OH, right? So notice here we have chlorine versus halogen, meaning that chlorine is actually going to win, right? But now, if it was instead a nitrate or a sulfate, for instance, let's just say the salt was not NaCl, let's just say it was NaNO3, sodium nitrate, right? So if the salt was sodium nitrate, we know that when it's split, we're going to have sodium and we're going to have a nitrate. So if it was not chlorine, let's just say it was nitrate, right? If it was nitrate, then it means it will lose, literally. So everything in this group loses. OH would have been the one to be oxidized, right? So if it comes from this group, it will win over OH, meaning that this will be oxidized instead of OH. But if it comes from this group, then OH will be oxidized instead of this, right? So this group wins, this one loses. So that's how it is. That's what you must memorize. So the halogen group and the sulfate and nitrate group, right? So that's how we determine which one wins between these two. Now let's talk about this one because they'll both compete in order to be reduced, right? So how do we know which one will be reduced? Because a lot of students, if they say write down the half reaction that happens at electrode Q, they'll be like, oh, obvious, sodium is going to reduce, and then they write it, and then boom, they see hydrogen. So how do we know which one is going to win? So this is the rule. So if hydrogen is competing with any metal, for instance, Na, right? If the electrode potential, not the charge, right? The charge is positive, I believe it's +1, right? So Na, the charge is positive, but I'm talking about the electrode potential, the one that we find in that table, right? That table with different values. So I'm going to prove it in a moment. So I'm going to prove it in a moment, rather. So how do we know which one will win? If the electrode potential of the metal is negative, it will lose. Hydrogen will win, meaning that hydrogen will be the one that will be reduced, right? But if instead the electrode potential of the metal is positive, it will win over hydrogen. So meaning that it's the one that is going to be reduced. So let's find out which one will be reduced. If they say write down the half reaction of what? If they say write down the half reaction that takes place at electrode Q, let's find out which one will win. Alright, so let's talk about this stuff. Let me see. So find this one. Do this. Okay, so now we're trying to find out which one will win, right? So we're comparing sodium, right? So notice sodium. It actually has an electron potential of -2.71, right? So there's an electron potential of -2.71, meaning that it will lose. Hydrogen will be the one that will be reduced, right? So remember, when we talk about reduction, half reaction, we're talking about a building up, right? There is mass is always gained at the cathode. So it means two things will join to become one, right? So meaning that we're going to write it in this direction from left to right. So we'll write it exactly as it is, except that we always put one arrow when we talk about half reactions. So that will be it. So this will be the half reaction that occurs at electrode Q, right? Just that we're going to write one arrow. So I hope you get it. If this was the one that was being oxidized, we would have written it in reverse because there is always a breaking down in the anode. It would have been this first, then it becomes two compound because of the breaking down. But because it is the cathode, we write it from left to right. So that's how it is. So we have question 9 here. So notice we're talking about electrolysis of ionic compounds, right? So this is a salt, so when it splits, ionic compounds. So they gave us the net cell reaction, right? So we have the net cell reaction. Alright, so now they say define the term electrolysis. So electrolysis is the process of using electrical energy to create chemical energy, right? So it's just as converting electrical energy to chemical energy, right, through ions, right? So that's how it is. So that's electrolysis, right? So you can check at the exam guideline, so you get the exact way you should write it, but that's the definition. So now here they said the graph is not drawn to scale and represents the changes of masses in electrode T during electrolysis. So what is important here is to note that is the mass increasing or decreasing. So they are saying that this is for electrode T, right? So the graph is drawn for electrode T. So now notice that as time proceeds, the mass is actually increasing, right? So what do you think? Is it the anode or the cathode? It has to be the cathode because mass is gained at the cathode, right? So that's how it is. So mass is gained at the cathode. So now they say write down the half reaction that takes place at electrode T, right? So um, so the half reaction that takes place at the electrode T. So we know that since it's the cathode, it's going to be negative, right? So now let's talk about the splitting of this stuff, right? Okay, so now we're looking for chromium. This is for A, and let me for B. So whether I use for A or for B, we'll get the same result. It's just that I'm used to 4B, not that 4A is difficult. It's by no means difficult. It's because I know where most of the compounds in 4B since I've been using it a lot. But whether I use 4A or 4B, it's exactly the same. So notice chromium is here. Yep, chromium is here, literally. That is chromium 2. Let's see. Let's look for 3. But it's the same situation. So chromium is here. Yep, so that's what we have. So it has got a negative electrode potential. Literally, I thought it was going to be the other way around, but it isn't. So since it has a negative electrode potential, it means that hydrogen will win, literally. So where is hydrogen? Hydrogen is obviously at 0, right? Okay, so hydrogen is here. So because it's reduction, it means that two things will build up and become one, right? So two things will combine to become one since it is at the cathode. So meaning that we're going to write it exactly like this. It's just that instead of 2 arrows, we're going to have 1 arrow. So that will be the half reaction. I don't think I need to write it down. We literally write this, but it's going to be 1 arrow instead of 2 arrows. Alright, so by the way, they made a mistake in this past paper. They broke the rules. And notice the next reaction, meaning that they were expecting chromium to win, right? So when you see this, they're obviously expecting chromium to win. But they broke the rules. In other past papers, they actually kept the rules. Here, they broke it. Alright, so now let's go to the next one. So we're going to go to a deep question, something that bothers a lot of students. So notice, so that was the half reaction. That so this part, right, this part is supposed to be hydrogen that won because the electrode potential of chromium is negative, literally. That is the rule. All right, so now they said a current of 2.5 amps passes through the cell for 10 hours. So this is what bothers a lot of students. Okay, so always remember when they just give you current and time, you just have to use that grade 9 formula. I is equals to Q over time, right? In any topic, if you just see current and time, you apply it. So even in photoelectric effect or electrostatics, you still do the same thing. So now they said a current of 2.5 amps passes through the cell for 10 hours. Now they ask for the total charge that flows through the circuit during this time. It's quite easy, right? This one we know we're going to apply the formula.